Hey folks, welcome back to another video. Today we're looking at question 23, merge case sorted lists. The way we will be approaching this problem is by using a priority queue. So let's jump right in. Let's first we need to check the base cases. If lists is if it is not populated, or if lists.length gdh is equal to 0, you would just return no. Otherwise, if everything is okay, you would need to initialize a dummy node. And the reason why we're doing that is because we need access to the first node in the list that we will be generating, the sorted list, when we're at the end of the list itself, because we cannot iterate back. So we'll create a dummy node, and we will have a head node that will point to the dummy, and in the end you would just return dummy.next. And the reason why we are doing that is because we'll be using head to keep a track of the last node that we added to the list, and we need to keep pushing head to point toward the most recent node to get access to the first node. That's the reason why we create dummy and return the next node. Alright, so the other thing we need to do is we need to create the priority queue before we jump into solving the problem itself. Priority queue, and then you will keep a track of list nodes in here. Let's call it PQ, new priority queue. We will be using a customized comparator where, given list node 1 and list node 2, you want to return them in an ascending order. So you'll just compare the values of the two list nodes. If this convention isn't if you're not too familiar with it, I highly recommend Googling it and looking it up. It's very handy for a lot of problems on LeetCode. Alright, so once we have the setup ready, let's add all of the first list nodes in the list itself. So for list node current in lists, you want to add that to the priority queue, but before that you want to make sure that it is not null. If it is not null, you would just add that to the pq dot offer current. And you might be wondering why we're adding just the first nodes and not everything else. We will see in a second why we are doing that. So once we have added all of the first list nodes from the list itself, we can go through the while loop. We would say pq.isEmpty. While it is not empty, you would poll list node current. So pq.poll. So this, you're getting the next node that has to be added to the return list, and you would say head.next is equal to current, and head is equal to current. And what you need to do next is you will check the poll that the node that we polled, if it has something that it's pointing to. So if current.next is not equal to null, you will add that pq.offer current.next. So the reason why you're doing that is because since we are adding all of the first nodes into the priority queue, we know that once they're added, we have at least k sorted nodes in the priority queue, but you also need to keep checking for the other nodes. So anytime you add a given node to the return list that we're adding right here, head.next, you're looking at the node, seeing if there's something that comes right after. If there is something that comes right after, you will add that to the priority queue, and you keep doing unless you reach the end of the priority that particular list. So that way you'll be tackling all of the nodes from all that are present in the list. So I hope that makes sense. Let me quickly run this and see if everything is okay. The first test case passes. Everything else passes as well. All right, so let's quickly talk about the space and time complexity. The time complexity of the entire solution is of n log n. The reason why it is the way it is because every time you're adding something to the priority queue, it also needs to sort. That's the reason why you have an additional log n right here, n log n. I mean, and then the space complexity is also of n because you need to keep a track of first all of the nodes in the priority queue itself, and yeah, I think that's it. We're not using any other additional data structures. Yeah, I suppose you're using it right here to create the new resulting list, but yeah, that would be often. Either way, the space complexity would be often. So let me know if you have any questions about this solution in the comments below. If there are any questions on LeetCode that you want me to solve, also please let me know in the comments below. And don't forget to like, share, and subscribe. I would really, really appreciate that. I'll see you all in the next video. Peace.